We did all of our vocabulary and boring stuff like that yesterday. Today we're going to do some examples, then we're going to do an assignment, okay? So we're going to start with looking at the example here at the bottom of this page, okay? So we're going to do the Skittles example first, okay? So what is your favorite color Skittle? Based on a very large sample, here is the distribution of colors for Skittles that come in fun-size bags. So actually, companies actually do like track how many of each color they like put out. Like, I don't know if you can find all of the ones for Skittles, but for M&Ms, you can see the different distribution centers and how they produce different numbers of each amount of the different types of Skittles, or not Skittles, like M&Ms, because of things like where it's located and how hard it is to get a specific color of dye and things like that. There's lots of things that go into it. So what this is it is the probability of selecting one of these colors, one of these 5 Skittle colors, out of a bag, like one of the small bags of Skittles. Okay, so we're going to pretend this is my bag of Skittles.
Sorry, Mr. Williams.
Yes, ma'am.
Kennedy Cotton dismissal.
Yes, ma'am.
Thank you.
Bye, Kennedy.
Give you your assignment. Here you go. Here's your assignment.
Yes. All right.
No, it's so hard.
So what that means, okay, is that I can stick my hand in the bag of Skittles and pull out one of those colors, right? If I can take one Skittle, that's my chances of pulling out the color. So yesterday, we talked about what a sample space was, right? So a sample space is all possible outcomes. So our outcomes for this is green, purple, orange, red, or yellow. And what do we know that what do all of the probabilities within a sample space add up to? 1. So if we were looking at this, we would have green plus purple plus orange plus red plus yellow is equal to 1. All of those things would have to add up to 1. So it asks us in question 1 to explain what the probability of 0.214 for purple means in this setting. So what does that mean?
These are the 21.4% chance.
Yep.
You'll find purple.
21.4% chance of selecting purple Skittle. Now, when we are answering questions about probabilities, usually we are not going to answer with a percent, okay? We will answer with the decimal equivalent or a fractional equivalent, okay? But when we do want to answer with a percent is if it says explain, okay? Because if I'm sitting here talking to you and I tell you, oh, you have a 0.21% chance, or a 0.21 chance of that happening, you're going to kind of look at me like, what do you mean? Right? Because it doesn't make as much sense when we're trying to explain what 0.21 is. But 21%, that's something that most people can conceptualize really easy, right? So whenever it says explain, that's when it wants you to use percents. Any other time, we will leave it as a decimal or fractional equivalent, okay? So now, number 2 asks us to find the probability for red, okay? So to find the probability for red, if I look at this table, it gives us all of our probabilities. What does it tell us? Does it tell us what red is? No, so we're going to have to find it, okay? So one way we can do this is to find the probability for red. We can do 1 minus the probability that it's not red. We can use the complement rule, okay? Because remember, the complement rule will allow us to take all of those things in a sample space, right, and find anything that's missing, okay? But in this case, what would I need to do for this one? How many of those things are not red? How many Skittles are not red? 4 of them, right? So I need to subtract all 4 of those things that are not red. So we're going to do 1 minus our green Skittle, our purple Skittle, the orange Skittle, and the yellow Skittle. And so if we do that, what is the probability of selecting a red?
197.
Did anyone else also get that and confirm? Because I don't have my answer key in front of me. So I'm trying to be better about confirming answers instead of just blindly answering them, because it never fails when I just blindly take them. They're wrong. Not that I don't trust you, because I do. Okay. Now, you could have also done this by adding up all the ones that are not red. So you could have added green, purple, orange, and yellow together and subtracted that total from 1. Either way works. Does not matter to me which way you do. Okay. As long as you're subtracting everything that's not red from 1, you'll get that answer. Okay. Now, it says, what is the probability that a randomly selected Skittle is green or purple? So, just take the bag. This is our bag of Skittles, right? And if we stick our hand in the bag and pull out one Skittle, can I grab both a green and a purple Skittle? No. Okay. So, are those two events mutually exclusive? Yes. Okay. When it's mutually exclusive, to find an OR probability, all we have to do is add the two together, right? So here, we have the probability of selecting green or purple. So since selecting green and purple is mutually exclusive, we can just separate that into the probability of green plus, it is union, okay, plus the probability of purple. So you can either use the or you can use union. So what is the probability for choosing green? Okay, plus what's the probability of selecting purple? And so if we add those together, what do we get? 385? Okay, if I wanted you to explain what that meant, what would that mean? All right, then, number 4 asks us, what is the probability that a randomly selected Skittle is not yellow? When it says is not something, that automatically tells us we need to use which rule? The complement rule. Okay, so to find the probability that it is yellow, you will say 1 minus the probability. Whoops, we're doing that backwards. Because we're trying to find that it is what? Not yellow. So to find the probability that it is not yellow, you're going to do 1 minus the probability that what? That it is yellow. And what is the probability that it's yellow? Okay, so what is the probability that it's not yellow? 7, 8. What was the last one? 6. So you have a 78.6% chance of not selecting a yellow Skittle. Okay, so we're going to go ahead and we're going to look at a high cholesterol example. All right, those of you that are on your computers, we don't need our computers today. Okay, and most of us that are on our computers are spending more time on our computer than doing what we're supposed to be. So let's go ahead and close those so that we can do what we got to do. Thank you. All right. So we are going to choose. Okay. So where this problem came from is if you were to choose an American adult at random, there are 2 events that this problem defines. So event A is that the person has high cholesterol. Okay. That means there is 240 milligrams per deciliter of blood of cholesterol. Okay. Event B is that the person is borderline high cholesterol, okay? So according to the American Heart Association, 0.16 chance of event A happening. So there is a 16% chance that they're going to have a random American adult is going to have high cholesterol. Okay, then we have the probability of B is 0.29, which means there is a 29% chance that a random American adult will have borderline cholesterol. So that is the information it gives us, and we can use that to find everything else. So first, are events A and B mutually exclusive? Yes. Why?
You can't have high cholesterol
So, yes. And it should be some form of, because you can't have high cholesterol and borderline high cholesterol at the same time. Yes. Okay, then number 6. It asks us to say in plain language what A or B is. Okay, because it's wanting us to find the probability of A or B. What is event A?
Having high cholesterol.
What is B? Okay, so if it asks us A or B, what is that asking it?
What the probability is that you will have one or the other.
So right here, this is asking us for the probability of having high cholesterol or borderline high cholesterol. And then it asks us to actually find the probability of A or B. Okay, we already said A and B are mutually exclusive, right? So that means we can just add together the probability of A plus the probability of B. So what is the probability of A? What is the probability of B? So what is the probability of A or B? So there is a 45% chance that a randomly selected American has not good cholesterol. Sounds about right, unfortunately. All right, so 7 says, let C be the event that a person has normal cholesterol, okay? So if their cholesterol is normal, what does that mean it's not?
A or B.
It's not going to be A or B, right? It's not going to be borderline or high. So to find this, we're just going to do the probability of C is equal to 1 minus the probability that it's not C, right? And luckily, what did we just find? So we can do 1 minus 0.45, which gives us what? Which means what? Yeah, exactly. There's a 55% chance that you have normal cholesterol as a random American adult. Which honestly is mildly concerning. And it's only 55. It's a lot of people that have bad cholesterol. Like, because there's some of it, I guess, that's the diet. There's some of it that's lifestyle. There's some of it that's genetic. So I guess it makes sense, but still. All right. Now, question 8. Okay. Question 8 asks us to find the sample space for rolling 2 dice. Okay. That is where if we take 2 dice, remember the first dice can be 1, the second dice can be 2, or second dice can be 1, the second dice can be 2, 3, 4, 5, 6. I've actually already written out the full sample space on the board over here. Okay. I have gotten tired of writing that sample space over the last few days. We did it a few pages back right here. That is our sample space for rolling 2 dice. That is the full sample space. How many things are inside that sample space? 36, okay? So there are 36 things inside that sample space. So now we're going to determine whether or not probabilities are possible, okay? So this is just, what do we know that probabilities have to be between?
0 and 1.
0 and 1, okay? So can 0.45 be a probability?
Yes.
Can 1/6 be a probability? Can negative 0.34?
No.
Can 8/3?
No.
Can negative 1/2?
No.
Can 0?
Yes.
Can 1?
Yes.
Okay, 30% is the same as,
0.3.
so can that be a probability? So if you get a probability and your probability is negative or above 1, you need to reevaluate said probability, okay? Now we're going to look at number 10. So number 10 is a fair die is rolled, okay? That just means 1 dice, okay? So before we start this, I just want us to recall, what is the sample space for 1 dice?
1, 2, 3, 4, 5, 6.
Yep, it is 1, 2, 3, 4, 5, or 6. It can be any of those, okay? So that is the only things we're pulling from. So it asks us first, what is the probability of rolling a 6? 1 out of 6. Okay? Then it asks us, what is the probability of rolling a 1 or a 5? Okay? How do we know how to find that? Since it's or, is rolling a 1 and rolling a 5 mutually exclusive?
Yes.
Yes. So we can just find the probability of 1 plus the probability of 5. What is the probability of 1? What is the probability of rolling 5? Which gives us? Which is the same thing as? All right. Then it says, what is the probability of rolling an even number? How many even numbers are in that sample space? 3. What are they?
2, 4, 4.
Mm-hmm. So the probability of rolling an even will be what?
1/2.
Well, what would I need to do before that, though?
3 out of 6.
3 out of 6, which is 1/2. Okay? If you jump straight to the answer, okay? These are questions that do not involve a lot of calculations, right? It's not like we're solving a bunch of things. We're just doing simple probabilities from a sample space or a table or something, right? Some of us can jump straight to here and get our answer, whether you're using a calculator or whatever, okay? If you do that and you get the answer correct, I'm okay with that. However, can I give any partial credit if you do not show any of this? No. Okay? And there's also something I want to make sure. I want to make sure you are setting up this part on your paper. I need to know what probability you are doing. Okay? I need you to set up at least this part and this part. Do you understand? Okay. Now, for D, it says, what is the probability of rolling a number greater than 4 and an even number? So how many numbers are greater than 4 and even?
4. 1.
What number is it?
Oh, wait.
Yep. Okay, so the probability of rolling a number that is greater than 4 and even. If I wanted to write that using the symbol, what symbol would I use for and?
The upside down U.
The intersection, yep. So, how many options did we have that's greater than 4 and even? 1 out of 6. All right. Now we are given number 11. So question 11, okay, has 3 of the 4 types of blood, okay? It has O blood, A blood, and AB blood. Or no, it has O blood, A blood, and B blood. It does not have AB listed. So that tells me we're probably going to have to find AB, okay? But it gives us to it in percents. Like 34% of the population has type O blood. 48 has type A blood. 15 has B blood. So what we're going to do first is I'm going to rewrite these as decimals. What is 34% as a decimal? 0.34. What is 48% as a decimal? What is 15% as a decimal? Okay. Now, it says find the probability that someone has A blood. So what is the probability of someone having A? of A.
Oh.
0.48. Okay. Then it says, what is the probability? Okay, that is what that means. If you would have just given me the percent, it would not have been right. You wouldn't have been wrong, but it also wouldn't have been right, if that makes sense. Okay? Because we want it, when we're writing the probabilities, they have to be between 0 and 1. Okay? We can explain them with percentages, but when we're writing them, we need to keep them between 0 and 1. So find the probability someone has AB blood. So we're doing the probability that it is AB. So if they have type AB blood, what do they not have?
OAB.
So what we're going to do is we're going to do 1 minus the probability that it's not AB. Which means we need to say 1 minus what?
0.24 minus 0.58 minus.
And what does that give us?
0.3.
0.3?
Oh, 0.0.
0.03. Okay. What is 0.03 as a percent? Only 3% of the population has AB blood. Because AB is the universal recipient. So it's the one that can take any blood from any type of person. Whereas O is the universal donor. It can donate blood to anybody. So now, find the probability that someone has O blood or AB blood. So the probability of O or AB. Are O and AB mutually exclusive?
Yes.
Yes, you cannot have two blood types. You will only have one. Okay? So we will do the probability of O plus the probability of AB. Okay, what is the probability of O? What is the probability of AB? So what is the probability of A or B? Or O or AB? Then it says, find the probability that someone does not have B blood. What rule do I need to use to do that? So the probability that it is not B. We need to do 1 minus what? Probability that it is B. So that would be 1 minus 0.15, which gives us 0.85. Okay, so that is the end of this section notes-wise. We are going to do an assignment today, okay? So I'm going to go ahead and pass it out, and then we're going to talk about a couple things about it, and then I'm going to let y'all work on it for the rest of the class. So we are going to turn it in. Yeah, I know y'all did. All right. Had an extra. So now we're going to look at this assignment real quick. So then I'm going to let y'all work on it. Okay. So for this assignment, okay, the first question says 1 coin is randomly selected from a jar containing 70 nickels, 100 dimes, 80 quarters, and 50 half dollars. Okay, 50 or half dollars are a type of coin that was more common back in the day. Okay, and it is exactly what it sounds like. It is half of a dollar. How much is half of a dollar? 50 cents. Okay, how much is a quarter? 25 cents. How much is a dime? 10 cents. How much is a nickel? 5 cents. Okay, now, how many coins in total are in the jar? There is 300 total coins. Okay, I say that because in order to calculate a probability, you take the number of favorable outcomes and divide it by the number of total outcomes. So you need to make sure you know the number of total, which in this case is 300. Okay, you can write it as a fraction and simplify it. Okay, or you can write it as a fraction and write the decimal. Either way works. Okay, so that's that one. Then this one here, if a die is rolled one time, so that is one dice. So what is our sample space for one dice? 1, 2, 3, 4, 5, 6. Okay. Then it asks us about if 2 dice are rolled. Okay. What is that sample space? That's that big whole one, right? Where there's 36 items in it. Okay, but it's the 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and then it goes this way too. Okay, it is a very big sample space. You do not have to write it on here. Okay, I just want us to make sure we know that that is the sample space it is talking about. That is why I wrote it on the board, so I didn't have to write it 1,000 times today, because I did that yesterday and I hated every second of it. Okay, so we're going to use that sample space. What does the word sum mean? You add them together, right? So it's like the 2 dice have to add together to give you the number it's asking. Okay, so I want you to take a second and work on that. Okay, so go ahead and work on it and we will check our answers here in a little bit. We are turning this in, so you need to make sure you get it done because you have plenty of time to work on it.